Hey, everybody, welcome back to your Dawn of Autonomy podcast. I'm Dawn Zoldi, your host, CEO of P3 Tech Consulting, and publisher at Autonomy Global. We are in August 1st. August, everybody. Yesterday, August 5th, was a historical moment in the United States as the Department of Transportation and the FAA published its notice of public rulemaking on beyond visual line of sight operations for the drone industry. So, how perfectly timed is this new month that we've dedicated to the theme of bigger and better? So, we're not just talking bigger and better aircraft with our sponsor here, Meadowlark Aircraft Company, but bigger and better regulations for the entire industry. So, we've got Ned Tabat. He is the CTO of this brand new company. Ned is a friend of the show. He was on in January to announce basically the launch of this company. They've been working hard all year long. They picked this spot knowing it would be a perfect spot. And boy, I don't know what you had in your crystal ball, Ned, but this is perfect timing. And it's such a pleasure to have you back on the show.
It's wonderful to be with you, Don.
Absolutely. And by the way, everybody, just saw Ned last week, and Meadowlark also sponsored our live stream from DC at the AUVSI Drone and AAM Policy Symposium. So if you all missed that, go back and watch it. Lots of luminaries, kicked off with Ned, and then we had Michael Robbins from AUVSI and everything like that. Ironically, right, it's a policy symposium and the actual policy came out like what, a week later. All good though. We got to see everybody, and that's really what it's all about. What an amazing community we have. But Ned, let's talk about you. You know, you have been leading this company with an amazing team out there in North Dakota. And for those that don't know your personal background, can you give them that 30-second elevator pitch?
Sure. I have all my degrees, including a terminal PhD degree from University of Illinois over 40 years ago. So it may have expired. I have to go check the bottom line there. But nevertheless, I've been in the industry doing mostly systems engineering and research work, mostly optics, some magnetics, relatively new to aeronautics, coming in from the sensor background. But back in January, I believe that when we talked about, I sort of alluded to the Elon Musk example of if you want to have Starlink, then you need SpaceX. And so we wanted to fly very complex, very novel sensors. These are both ground penetrating radars and active multispectral cameras for infrastructure inspection primarily. We needed a
Yeah.
platform that had long endurance, and we couldn't do that. And so then the decision was, and this is like a couple of years ago when we were looking to find the right platform for those types of sensors to integrate on. And then the decision was to actually go ahead and build the platform ourselves. And then we see an opportunity, a great opportunity for the overall platform, in addition to all the sensors that go on it. But because I come from that background, I know the value of having a lot of excess power on board. So we intentionally built this vehicle to have a couple of kilowatts of excess electric power on board in order to be able to not only power active sensor packages, but also do edge computing at a large scale. So you can run many GPUs on board, do a lot of onboard data processing. So, and then again with the Starlink connection, be able to do real-time downloading of that information. Very important for ag applications, but also for pipeline and energy type inspections as well. And the
Yeah,
reason,
100%. I was gonna, I don't mean to cut you off, Ned, but I was gonna say I actually had people reach out to me, they see me on LinkedIn or whatever, and it was a guy that was in the O&G world, and it was kind of a methane thing, right? Looking for the kind of vehicle you're exactly talking about. So there is for sure a need out there, and It's an interesting origin story because you had the sensor, you had the use cases lined up. And then the question is, where's that hardware to fly this thing that we want to fly? Let's just make it. But beyond that, Ned, you didn't just make a drone, and we're gonna dive deeper into your drone here momentarily, okay? But you also decided, well, let's not just build an aircraft. Let's build an entire factory that can make this aircraft in the US, in North Dakota, and that can make others aircraft as well, because there's this need, right, for US manufacturing, and you saw that need as well. So can you just briefly tell me a little bit about the origins of that manufacturing line of effort and kind of where you guys are with that? And then I want to talk about your 5 Bs.
All right.
Okay. So, but first, before we do that, tell me about the whole manufacturing idea and how you hatched that.
And so again, it's all about the ability to meet the demand for a certain group or size of an aircraft. And so you can see that volumes of injection molded Group 1, very light aircraft that are being built, Ukraine, Russia, China, they are making millions a month for essentially these are attributable, if not one-way use. And so that side of the spectrum is pretty well covered. But the Overton window is not necessarily changing, but it's widening. And so we're now talking about Group 3. And Group 3 is such a large range that generally Group 3s have been built onesie, twosies, and not very many in volume. So we saw a need for having volume manufacturing capacity for the lighter Group 3 as again we go heavier and heavier as the use cases demand more capability from these aircrafts. But so as part of this manufacturing was that, yeah, maybe I have a use case, maybe I'll buy 20 aircraft a year for that particular application, but we want to build a factory that builds 600 aircraft. And I think that's the right size for us here in North Dakota to plan for 600 Group 3 aircraft a year. And for that purpose, we have to be able to open it up to white label manufacturing. So if you build a very nice aircraft, go win a DoD contract, and all of a sudden they want 200 of those, it behooves you to talk to us and let us build it for you in volume.
I
And so
love
that
that,
is
Ned. And by the way, I gotta say, we the chat is blowing up a little bit. We got Ross out there, ray of sunshine, saying good day. So good day to you, Ross. And Bill Schultz has become a super fan of the show. Good morning, Dawn and Ned. What a great time coming. And I think that comment is a great segue, maybe to our first slide. And when we were in DC last week, Ned was joking with me, it was bigger and better month. He's like, but I've got 5 Bs. I've got five, not just bigger and better. There's five. So here they are. And Ned, walk us through. I know this ties directly into your motivation and founding of Meadowlark Aircraft Company. So tell us your 5 Bs and why they're so important to the industry, especially now as this new rule is going to open the skies to bigger and better aircraft.
absolutely. So as I mentioned, the attention now is going to focus to heavier aircraft. It really opens up the use case. Still want to be vertical takeoff and land, at least we do. And we still want to be able to have the capability to do rapid assembly in the field, at least for the smaller aircraft. But beyond that, we're moving to heavier aircraft, hybrid propulsion, so you can have longer sorties. Like I said earlier, a lot more onboard power capability, so you can do a lot more interesting stuff in terms of computation, edge computing, as well as active sensors. So bigger is definitely in vogue right now with the Part 108 going in and expanding the use case. The low-hanging fruit is going to be rural infrastructure inspection, precision ag, and then pipeline or other energy inspection. All of those things can benefit. Well, I give you an example. We can inspect with a ground penetrating radar. We can expect 1,000 miles of buried pipeline for leaks in one sortie, which
Wow.
is replacing 2 or 3 manned aircraft that in the past or currently they're using. And of course, we can actually because our stall speed is so much lower than manned aircraft, we can go a lot slower. We can actually hover if we need to, if we somehow detect an issue that we need to further examine. Again, having onboard computing and machine learning capability is really critical for that. So that's the big.
And Ed, before we, so you're kind of, we talked about the bigger a little bit. I want to elaborate on that and better in a second. We're using these bigger sensors to get better data, with less aircraft. But just to be clear for everybody out there, because I don't want to assume people know, we're talking about your FH125 Strix. Is that right?
Correct. Yes.
Okay, so this is the Meadowlark FH125 Strix. By the way, when you're talking about bigger and better, this thing's got a 16-foot wingspan, and that's why I can carry these heavy sensors, the better sensors, if you will, that Ned is talking about. Let's hit, unless I missed something in the bigger better, let's hit bluer, because I think that's kind of the term du jour, right? Like blue UAS. Everybody's talking about made in America. We're seeing executive orders unleashing American drone dominance. That was actually on the podium. That tagline, if you will. When the Secretary of Transportation yesterday unleashed the NPRM for 108. So how is the Strix
Yeah.
bluer?
So
How's it blue?
sure, we're tapping into a secular trend for onshore manufacturing. We're bringing back a lot of the manufacturing. Now, airframe manufacturing is not exactly heavy manufacturing, but still very energy intensive. And so that aspect of it is pretty clear. And that's what most people talk about. But now you got to go down the food chain into some of the subsystems that feed into the overall aerial system. And particularly when it comes to propulsion and some of the avionics that we also, when I say bluer, of course, I wanted to stay with the theme of bigger and better, but bluer, we can't totally rely on everything US sourced, but that is the direction. So we do have other, mostly NATO sourced material, but we ought to bring a lot of that back on shore, particularly some of the subsystems that historically have been lost to U.S. manufacturing, and they cost a lot of money to set up those fabs, the chips and the MEMS, and all of those fabs are quite intensive in what it would take to create them here in the U.S. But that is the trend, and uh, and I see also, for example, on detect and avoid avionics. Right now, we use a lot of sensors that are designed and built for automotive autonomy, but to get
Interesting.
it into aerospace autonomy, they really need to have different requirements. And so I think as an industry, we need to define those requirements better so that we can attract suppliers that come to the US. These are generally Southeast Asian, come to the US and build the factories here
Yeah.
and build those to our specs, to our requirements, as opposed to
It's a great segue to your next B, which is BV losser, beyond visual line of sight. Again, big news yesterday, unless you've been, completely remote or living under a rock. I think everybody knows by now in the last 24 hours, we had this Part 108 rule come out. It's over 700 pages long of goodness. But here's the thing, everybody. It is not the end rule. It is not the final rule. It's not the be all end all. there is a 60-day comment period that has, at least in the last 24 hours, not been extended. So my guess is somebody's going to, or some groups are going to say, can we have more time to digest this thing and make comments? I don't know if that will be granted by the FAA. They did not grant that any kind of extensions, my memory serves, for the remote ID rule, which, by the way, drew in 53,000 comments. So my message to all of you is read the rule. Don't just read the summaries. I admittedly put out a very, very brief summary yesterday on Autonomy Global, but it doesn't even come close to scratching the surface of this rule. You have to read it word by word, which I'm going to be doing deeply during my 7-hour car ride later today. So expect more stuff coming out of Autonomy Global. By the way, we also have a whole bunch of our ambassadors energized and writing articles from their perspective. Today, Dan Julin wrote and published about how the FAA looked to Canada and, the Canadian regulatory structure and what they were doing up there in finalizing this NPRM. So check that out. Really interesting. Tomorrow we're talking SMS with Juan Plaza. But let's talk about how your company, your drone, your manufacturing, Ned, is all about BV loss.
So I want to give a shout out to our flight ops director, Brad Schiff, who read through the thing last night and briefed me this morning about what's in it. But a couple of things that are important to us. I'm going to start out with what probably something that's not obvious or may have not been obvious to a lot of people who were talking about it online, and that is when you go to these larger aircrafts, um, then you're dealing with now no longer FAA assigned pilot training programs. And so the platform manufacturer is going to have to provide that pilot training for their clients. And
that's
we
going to be you.
anticipated this. What's that?
That's going to be you.
So we anticipated that in the past, and we are putting together the capability to do that within our company for our own aircraft and for any aircraft that we build as a white label as a contract manufacturer for anybody else. We would take on the pilot training role, but we're kind of like the big boys now. I mean, General Atomics Reaper pilot training program is just down the street from us. And so when we're looking at what that entails within Part 108, it confirmed that, in fact, we were on the right track getting that set up. The other differentiation between us, and so that's different for, let's say, Group 3 or than Group 2, where Group 2 can still continue to use Part 107 pilot license. The other thing that's different is for us, specifically for the type of aircraft that we're building, is again the focus on rural infrastructure, whether it's delivery or inspection. We are looking at not necessarily a UTM type of a control system. So UTM being unmanned traffic management. So there's a lot of emphasis on how that's used for companies who do a lot of delivery in urban or suburban areas where they need the population density to make that business case viable. For us, that's not necessarily that important, but also that means that we're not going to cover the country or the world with ground-based radar to set up UTMs. And so there's going to be a lot of onboard detect and avoid capability. We keep coming back to that. I have a passion for that. There's a lot of that has to be on board. Again, drives additional power requirements on board the aircraft to be able to implement these more complex detect and avoid technologies. And how that comes into Part 108 actually will be interesting. One of the things that we did hear last week was that, for example, these companies that have been operating under waivers, they're going to ask to have that be grandfathered into Part 108, the techniques that we're using. For us, because of the heavier aircraft, that's all going to be new. So it's just going to be very interesting. I don't know how that grandfathering will work if we'll have no longer a single standard. We'll have multiple ways of doing things. That would be interesting. That will shake itself out, I think, over time.
Yeah.
Uh, but we intend to bring in onboard detect and avoid because for rural inspection, you can't really expect to have UTM available for.
Yeah. Well, first of all, I wanted to say a couple things. Mark Ganong out there from the Nevada test site. We saw him last week too. Another super fan said he's on page 91 of this thing. And Ray Sunshine is saying again, thanks for this deep dive into the new reg a little bit. But we're not really deep diving into the new reg because there's just so much to unpack, and it's going to take days, maybe even weeks, honestly, for all of us to really get our brains around it. So I just kind of throw that word of caution out as you're, kind of reading things. Understand a lot of the initial commentary is very high level, but the devil is in the details, as they say. And Ned's getting into some of these. One thing, spoiler alert, everybody. If you're doing beyond visual line of sight, basically that you're going to have detect and avoid. Period. Dot. Like it's in the reg. I don't think that's going to change in the final rule. That's going to be something that's going to be required. So like Ned said, what that looks like in the end, air ground combination, and that's the other point. This regulation is performance based, so it's not prescriptive. So this is going to be, there is no one size fits all. Like everybody must have X on board. It's, well, if X and Y plus Z works, then we're gonna, say that's good too. So, there's going to be a lot of dynamic changes along the way, lots of different things happening. It's going to be an exciting time to be sure. But let's get to your last B, and then I want to get into this drone. Bespoker, bigger, better, bluer, BV losser, and bespoker. Tell me what bespoker means.
And so we kind of usurped that term from I guess, men's fashion, where we actually tailor the sensor package of the aircraft. That's primarily has to do with the sensor package for the larger aircraft to the use case that the client wants. And for example, like I said, right now we're dealing with two very distinct client bases. One is precision ag. They want to detect, well, right now the low-hanging fruit there, pun intended, is to do moisture measurement, direct moisture measurement, which you can't do any other way. You can't really use satellite imagery for that because satellite is passive. That portion of the spectrum is solar reflection spectrum is absorbed by the atmosphere, and so it's pretty dark, and so you can't really look at direct moisture. So they usually measure chlorophyll. But we can do that with active sensors on board and also flying very low so we can get very good resolution. And that is real-time transmitting to irrigation systems. Very, very important capability that we're going to bring to bear with our FH-125. The other one is
Okay.
ground penetrating radar.
Oh, good. The GPR, ground penetrating radar. I learned all
Absolutely.
about that at Geo Week. I'm walking around the floor and they've got SAR, they've got GPR, they're getting all the three-letter acronyms, and it's always an education whenever I go to a show. So yeah, using GPR, ground penetrating radar, as part of your bespoke model is super important. But let's talk about the model itself, because
Well, and then I'm going to add somewhere to the bespoke,
okay,
and
go
that
ahead.
is that uh, we can also, well, having a digital twin for the aircraft, which we do, and it's very important for DoD applications. If you're dealing with most modular open architecture systems, open systems architecture, uh, you need to have that, and we provide that. For example, if we build for anybody who's dealing with DoD and they need to have a digital twin of their aircraft, we also provide that service. That's a
Oh, very
plug for
cool.
the company. But more importantly, that when you're dealing with that, then you have to open up your modeling system to be able to do more degrees of freedom that you would not necessarily handle. For example, the shape of the airfoil of the aircraft. So to demonstrate that, we're doing a lobster-shaped airfoil for a particular client who's doing high-end food delivery. And you want your sushi and your Chardonnay delivered by a flying lobster, which is takes a lot of work to actually design the aircraft to make it efficient, make it stable, make it capable, and still have the airfoil, that shape that you want. And
By the
so
way, Ned is not joking here. Like, I literally saw the flying lobster at, was it AVSI? You guys had it at your booth?
we had a video of it, but yeah, we'll have it.
You'll
We'll
have
have
it
an.
in North Dakota?
We'll come October.
Yeah.
Um,
So what Ned is talking about
UAS
is,
Summit.
yeah, the UAS Summit in North Dakota, second week of October. I will absolutely be there. Looking forward to it. I want to see this flying lobster. Ned, I joke all the time. People think of drones. A lot of drones just look like these flying spiders. Okay. And like, can we make them look nicer and happier? But dude, you're making a freaking lobster. I don't know that that's better because lobsters, as like, crustaceans go, are kind of weird. I don't know if I'd be super happy seeing a flying lobster coming over my house, but I can't wait to see this thing, my friend. This is so cool.
You will love it. You will love it.
I know I will love it. We'll get you a
You will love the
lobster.
sushi and Chardonnay that comes with it. So
Yes, and we'll get you a lobster time. By the way, Morgan McCauley's out there saying good morning right back to you, Morgan. Thanks for joining us. So once again, we are with Meadowlark Aircraft Company, Ned Tabat, the CTO, talking about all the amazing things they're doing up in North Dakota, not only building a manufacturing facility for up to 600 Group 3 drones a year, bespoke, but also their own aircraft. So let's talk about this FH-125 Strix. And I think
and
we have
so
a slide. So let's pop this up. Want to show kind of talk about the different market segments and the gaps you're really targeting with this drone.
um and so what I try to capture here is how the Meadowlark focus fits within the spectrum of the drones out there, and everything from these are DoD classification, but I think FAA uses exactly the same nomenclature. From Group 1 through Group 5, so Group 1, I think that's the Skydio, to Group 5, that's the Northrop Grumman RQ-4. That's pictured
Is Group
there.
2 on your picture the little
It
lobster?
is. That's our
Oh
lobster.
my gosh, dude, that is hilarious. I love it.
And then, but our focus primarily is going to be on Group 2 plus, we call it, but it really is technically is a Group 3. So if you notice, there's usually a factor of 2.5 between these weight classes, except when you go from 2 to 3, then it's a factor of like 50 or something. Haven't done the math, and I don't want to do it now. But
As a rule, Ned, I don't do public math, just so you know.
all right, good. And so we needed to kind of put some sharps and flats between those two notes. And so what we were talking about Group 2 plus is 125-pound takeoff weight. You probably noticed that our aircraft we're very proud of it. We think it looks very slick, but it's not all that different from everybody else's. Everybody's building roughly the same thing because that is what inspection aircraft for that size would look like for a hybrid one. Next size up is going to be intermediate distance, intermediate weight package delivery. Again, we got to eliminate all those trucks that are out there carrying 4 tires from a warehouse to a Napa dealer in the middle of nowhere, right? And so that's my criteria. It has to be able to carry 4 tires, 150 miles. And so we're designing another aircraft, but that design point also is starting to, you see 1 or 2 of them out there now in the industry, and that's starting to take shape as a form by itself, which is designed for cargo.
So heavier cargo. Now I got to ask you, the gruss. You've got a picture of a bird there. I assume that is in fact a gruss. And why
That
this bird? Why this bird?
um, why does what?
Why did you pick this bird? Why this name?
Oh, we just named everything after birds, and I think that's a Latin name for a crane, and so
Ah,
therefore I have a picture of a crane. But we will unveil our design here, well, probably about 6 months from now. But honestly, it's going to look like everybody else's, very similar to everybody else's. There's no reason to not use what works well.
yeah,
And
of
so what
course. I
we
mean, you could always
make our
throw,
name
you know,
is quality and volume.
yeah.
Um,
Well, and Ed, honestly, there's color. I'd love to see a pink drone. I've only seen one in my entire life. And that drone happened to be a little tiny, kind of one for school age, probably girls. And I'm like, yay, amen. I see a pink drone. Let's go there. So Fixar's got the beautiful red drone. Wingtra's got their orange. I and Census Technologies kind of orange and white. I'm going to go out on a limb. I haven't really seen yellow. I haven't seen pink. Green doesn't quite work, but maybe a better green than the one I've seen. Just throwing it out there. You can differentiate
I
it
think
by a cool color. It doesn't have to be a
there's a
lobster.
French company called Yellow something that does build yellow
Oh,
American.
yellow scan, the
Yellow
sensor
scan,
company.
yeah.
Oh, that's true. They do have yellow drones. You put me back in my place there. But let's pop up this slide on your bespoke design for the FH
But
125 Strix.
yeah, I think we should go to slide 3 actually, so
Yeah,
that
let's
be
get
easier
that
to
up
talk
if
about.
you don't mind. Here we go, I think, in a second. And while we're waiting for the slide to come up, here it is. We have a question from Morgan. What is the empty weight of the lobster, by the way?
Oh, that's a group 2. So actually, empty weight is 40 pounds, and then 15 pounds of pizza and beer. So 55
Or
pounds.
sushi and
Or sushi and Chardonnay. Absolutely.
no, not
Champagne.
Chardonnay, my friend. We're talking
Champagne.
soju. Anybody that has sushi knows that soju is a thing. It's
Um,
awesome. So I'm just throwing that out there. I had one more
I
question, and then
I
let's go
didn't
to
think I would learn something this morning, but then Brad educated me, and now you do. So
well,
we're good.
you got to try soju, SOJU, if you've never had it. It's crazy good,
Never
but
had
it's
it.
very high. It's like 13% alcohol by volume. All right. So Ross is asking this really important question, and it actually goes back to the reg, and then we're going to get to your design. Who is going to do the inspections on these larger aircraft? Do you know that answer, Ned?
Who is going to do the, well, we have our own compliance team
Yep.
that would do the flight tests and all of that. And then obviously we have to work with FAA to, um, so some of that, again, I was getting briefed on how the inspection will change from what is in the proposed ruling. And
Yep.
so we would have to get better educated on that. But we are going to, but it's going to be internal to Meadowlark. I think that's the question, right?
Yeah,
And yes,
I think so, but I think you're right, Ned. Again, I gotta read it deeply, but my understanding is the FAA is, of course, not ceding their inspection, authority, and they're going to be doing inspections of some of these larger aircraft just for safety reasons. But let's talk about the Strix. Our time is flying because you and I have been talking about so many different things. I knew it would. It always does. And by the way, to continue the conversation, everybody, with Ned, go back and watch his original video also from January, and then on the Dawn of Autonomy. And of course, join him live in North Dakota in October. If you've never been to the UAS Summit, it's a phenomenal event, kicking off with Grand Sky on Monday, happy hour out there, and then, the actual main event. But okay, Strix. Let's pop the slide back up. Sorry, my amazing producer in the background, because I talked over it. Let's just walk
okay,
us
so
quickly, hit the highlights.
okay, 125 pounds, and I think we said 10 hours, but that is with full 35-pound payload and 2 kilowatts of power. But we could do a 20-hour flight. You just have to slap another gas can on it. And this is a hybrid propulsion, two-stroke engine in the back, um, and VTOL. But what really is special about it is, and so here if you have an aerial system, then of course it's comprised of multiple subsystems, and I've listed that on this slide. And the six on the left are on board the aircraft, and the three on the bottom are support systems that are not on board the aircraft. And so because we're building a digital twin of the aircraft, each one of those subsystems also have a digital form that can then be optimized. The easy way to explain that is, where's the center of mass moving if I take this gimbal out and put this particular sensor on, and so on and so forth. But it's more complex than that in terms of noise interference between different systems, cabling, all of that. And so for that aircraft, I mentioned two use cases, and you actually added some to it with SAR. So for example, with GPR has to go hand in hand with SAR because the resolution otherwise wouldn't be good enough. And so now you're looking at, how to get the aircraft to be stable enough in its performance to be able to do synthetic aperture while you're flying. The other thing is the capability to hover for the aircraft is very important. So when you're doing these kinds of leak detections, for example, you set your detection threshold to be very, very low. So your beta errors are going to explode, but because you don't want to miss any, it's very critical that if you see or if you detect a leak, that you identify it. But because you're setting that very low, you get a lot of false alarms. You have to be able to, on the same sortie, go back, hover, take deeper data, and then move on. And those are the capabilities that we built into our system, both from the avionics, the sensor capacity, and also the control firmware that goes on the aircraft to be able to do that.
And so then, you're alluding to it. I mean, look, the drone collects the data, but you're talking now about the analytics on the back end. So are you also making that?
I'm going to add one more things on the aeronautics, because it's very important. That transition between vertical hover and going on the wing is a really critical aspect of getting the firmware right. And the more I learn about that, the more excited I am with our approach to doing it. And
all right, so that is the Strix a VTOL?
Of course.
Okay, so it's vertical takeoff and landing. All right. Just by looking at it, that wasn't like patently obvious.
The propellers on the pylons are kind of lined up with the pylon to reduce. They go into that to reduce air resistance. And
okay, so that's awesome. That makes it easily deployable. My understanding also, it's just about field. It could be a field assembled in under 15 minutes. It's ruggedized, so I think you're ticking all those check marks for really almost any market, including DoD, as you were kind of designing this thing, which is amazing. Am I going to see a big Strix also? Am I going to see this thing in North Dakota? Can I?
That's a good question.
All right. Well, I'm coming to your factory.
Huh?
I'm coming to your factory.
But let me talk about factory, because the reason you can't just build one Strix, so you can, but you wouldn't. We got to be prepared to build many, because the molds for that thing are so expensive that we can build a small scale version and fly it, learn a lot about the flight characteristics. But to get the full size, which is what you're asking, that is I would say that's probably not going to be ready by October. We're going to be ready in time for when FAA will let us sell these things nationwide, but we will be able to fly them in North Dakota under our waiver next spring.
Excellent, excellent. Now we've got this manufacturing slide up because this is something you're obviously gearing up to do.
We only got a couple of minutes, so I won't spend too much time on it. But um, again, our focus is going to be on manufacturing, and we're putting in a lot of infrastructure to manufacturing requirement planning, and all of that software that goes with it as part of a total enterprise resource planning software that controls the system, controls the supply chain, so you can actually have the number of aircraft that we intend to build in a relatively small 100,000 square foot facility, build 600 aircraft, and turnaround time of about 2 weeks. And so you will see that it's going to be fairly complex, but we want to be a cost leader as well, and that really speaks to that. So what I really want to say about this, and I'll say it in 30 seconds, is that when you add the bespoke part is when you add any novelty to the design, you are going to add additional risk, additional cost, and additional delay. And so by setting up all this stuff that you saw on the left, doing it the way we want to do it with advanced manufacturing techniques is to squeeze that curve down, so live in between and take that margin for a profit margin. So that probably a longer conversation to be had, maybe at one of these conferences we should do.
Well, look, there's plenty of time to talk. There's many things to look forward to in the coming months. Of course, we're running short on time here. We've got about 3 minutes left. I do want to ask Morgan's question because it is a good one. Do you have a preference on a ground station for your Strix or your upcoming Gruss?
So for Strix, yes, we do. The actual flight, of course, needs, at least for now, for probably some time, needs a pilot. It could be one too many pilots. So if you're doing pipeline inspection, you have 6 aircrafts up in the air at any given time, or let's say border patrol, and you have multiple aircrafts that are patrolling a fairly long border, you do need a pilot for at least every 4 or 5 aircraft. The other thing is that you probably need a sensor operator for each one of the aircraft. So in our vision is that maybe if you have 6 aircraft up at any given time, you have one individual that's flying them or monitoring their flight, and then you have 6 individuals who are monitoring. I mentioned a little bit about, okay, detecting a leak, having to go back and work with the pilot to go back and do all of that. And so a ground station is probably going to be larger than most people. Definitely has to have satellite connection capability, because a lot of this real-time data has to bounce off of Starlink or similar. And I'm anxious to find out how your Starlink works.
Yeah, so I'm going on a trip, and I have a Sprinter van I'm going to be in for a little bit, and we do have Starlink. So I'll let you know how it goes, Ned. It'll be obvious because either you're going to get a draft article soon or you're not. So that you'll know just by that. But look, we've got now like a minute left, and you've got other things on the horizon. You've got this FE050, FH300, whole family of VTOL aircraft that you're making. Everything is kind of on the whiteboard right now. But it sounds like, Ned, you've got Strix in the crosshairs. You've got Gruss slated for 2026. And then some of these others coming up. What else can we...
RE050 is that decapod. We call it decapod being crustacean. So that aircraft actually has a buyer. So we just...
Wow. This is the Lobster, this FE050.
It's called a decapod. It's actually, yeah.
Okay. And what about the FH300? That's a 300 pounder?
That's the Goose. That's the Goose.
That is the Goose.
Heavier aircraft. That's a 300 pounder.
Okay, and that's the 2026 horizon.
Yeah, that's for intermediate goods transport. Like I said, be able to transport 4 tires, 150 miles. So
Okay. Holy shnikes. All right, my friend. Well, look, we are at the end of our time. I want to make sure that you have an opportunity to make any concluding remarks, Ned, and then please tell people how they can reach you and find you next.
Meadowlark aircraft, if you Google that, I think we're fairly well search engine optimized. So you should be able to find us
You
very
should,
easily.
but it's Mac ND,
Oh,
like
either one
Meadowlark
works.
Aircraft Company, North Dakota. If you can't find them the other way, that's the way to go. Mac
If you don't
ND.
want to type, if you don't want to type a bunch of
There
letters,
you
then
go.
you can also do meadowlarkaircraft.com. That goes to the same place.
Gotcha.
And myself personally, LinkedIn probably the quickest way to find me. There are
Yeah.
not too many Tabats out there, so you should be able to find me.
And then, check out Ned and his Flying Lobster in North Dakota in October, if not beforehand. I'm sure if anybody's visiting the area, Ned, you probably welcome them with open arms, I imagine. So reach out to Ned on LinkedIn, learn more.
Yeah, I
like
do want
said,
to shout out our headquarters right now is in downtown Grand Forks in a building called the Hive, which is the
oh, the
UAS.
Hive is so cool.
Yeah,
Yeah.
and so come see us there.
Yeah, the Hive is like a makerspace. It's an accelerator hub right there in downtown North Dakota. Got to see that last year for the first time when I visited. Really cool stuff happening in that state. So glad you're a part of it, Ned. Thank you again for taking the time. Thank you everybody for the comments in the chat today. It was awesome. Appreciate you. Like I said, please follow Ned, but also follow Autonomy Global. Sign up for our newsletter if you haven't yet. And absolutely check out the webpage every single day. We're popping up something on this new rule, some new perspective through all of our different ambassadors. It's awesome. So that's all
That's the
she
first
wrote.
thing I look at every morning, Don.
Oh, thank you. I appreciate that. All right, everybody, we are out here.